Thank you, Dan, for your introduction. And you did pronounce Edinburgh correctly.
Okay, thank you.
Okay. You should be able to see a screen that says Tools for Exploratory Data Analysis. Can you see that?
Yep.
Great, lovely. Then I'll start. So, I'd like to start with a quote by a famous statistician, John Tukey, in 1986, where he said, exploratory data analysis is attitude, flexibility, and graph paper. Now, we can't do much about aptitude and flexibility, that's inbuilt in all of us. But maybe 30 years later on, we've got a better graph paper. And I'm going to suggest 4 improvements to graph paper. They're Excel, R, Azure Machine Learning, and Rapidminer. What we're going to do is we're going to do an analysis of a small data set using each of those 4 tools. Now that might sound quite boring, repeating ourselves, but we have the same objective, but we do things in a very different way with each of the tools. First of all, we're going to start with Excel. And why Excel is more Power Query and Power View. These are the Power BI add-ins to Excel. And that's basically our yardstick. We all have Excel on our machines. Most of us love it. We all know it. And if we're going to use a different tool to that, then there has to be a pretty good reason. So we're going to start with Excel. We're going to load some data in with Power Query. We're going to visualize it with Power View. After that, we'll have a demo of R, and we'll do the same sort of things. We'll be using, in particular, a couple of R packages, GGplot 2, which produces very good graphics in one line, and dplyr, which is good at manipulating data, projecting it, filter it, and so on. And you'll see some examples of that. Then we'll go on and look at Azure Machine Learning and what we can do with that. And that's Microsoft's machine learning in the cloud. Finally, we'll have a look at Rapidminer, and we'll do that quite briefly. Rapidminer and Azure Machine Learning follow the same design philosophy, which is a kind of flow chart of shapes or actions and data and connecting data flowing between them. So once you've seen Azure Machine Learning, then Rapidminer will be familiar. And there's many other tools that have that design philosophy as well, such as Alteryx or KNIME and so on. All these tools are free to get started, or at least very cheap to get started, or obviously is open source and free. Azure ML is a free month starter package, and then actually designing the ML experiments is free. It's only when you actually start putting them into production that it starts costing, and then again, it's cheap for testing. Rapidminer is a commercial product, but it has a free starter edition, and that's not time limited. It's limited in the sort of files and the capacity, but for exploring, it's great. And you've probably got Excel on your desk already, and Power Query and Power View are add-ins onto that. I'll be showing you some demos, and all the code will be available, all the links to the code will be available on the site there, http://zomlex.co.uk, and there'll be a link to a OneDrive off that, and all the code will be available and the slide deck afterwards. Very quickly, Dan has already introduced me. I'm work in London, where we have a beautiful sunny day here today. I'm a freelancer. I work in the finance industry. Some of my previous clients are on the right-hand side. On the left-hand side is the kind of evening job. I'm the organizer of a group called the London Business Analytics Group, and we have monthly meetings in central London about any topic of interest in data and analytics. We've just had one on machine learning. On Wednesday, we're going to have one on big data visualization, and then in July on Hadoop. We don't do deep dives. We take a kind of business and entrepreneurial view of all these technologies. So if you're in London or about, please come along. If you Google Meetup London Business Analytics Group, you'll find us. We normally have 100 people. We have drinks before and pizza afterwards. So to try and persuade you to come along. Now it says there that I specialize in analysis, reporting, and visualization. And I wish that were true. I spend most of my time delving deep into data, munging data, cleaning data, and getting it ready so I can do the analysis and the reporting and the visualization. And so in my job, I get a lot of data details of financial trades, the currency, the bonds, counterparties, who traded it, when it was traded, the notional, details of counterparties, issuers, credit ratings, prices, FX rates, volatilities. So I have an awful lot of data at me, and it never is in very, very good shape. It's, the producers always claim that it's better than it is, and I have to spend a lot of time improving it. And I wish that I had some of these tools a few years ago, because the tools I'm going to show, I think, make that kind of initial exploratory data analysis of the data to find out what the problems are and to understand the data a lot easier. I said that we're going to look at a data set, and for the purposes of introducing that data set, I want to imagine that all of us are going to organize a cruise. Maybe the next past BA conference, instead of being in California, is going to be in a cruise. And I want you to think, I want to ask you 3 questions, and you'll see the reason for this when we get to the end of the talk. First of all, if we're all coming to the cruise, you have to, I need obviously details like your name and your age and all those, but 3 things you can choose. First of all, do you want to travel first, second, or third class? Secondly, and you're paying for yourself, by the way. Secondly, who are you taking with you? And I want that reduced to 2 numbers. First of all, the numbers of siblings and spouses, which are called SIB-SP. So if you're taking a wife and a couple of sisters, that would be 3. And secondly, your PARCH number, which is the number of parents and children you're taking with you. So I just need those 2 numbers. And then the cruise is going to start off in the UK, in Southampton, and go across the English Channel to Cherbourg in France, where I pick up a few people there, then on to Ireland, to Queenstown in Ireland, and then we're going to sail across the Atlantic and hopefully arrive in New York. So make those decisions for yourself, and we'll come back to those later on. Now, most of you will have realized that there's a bit of a flaw in my plan, in which case, in that the boat has already sailed. It was a Titanic, of course. It sailed in 1912, in April 1912, with 2,200 people on board. And it sailed and it sank. It hit an iceberg halfway through the Atlantic, and of the 2,200 people on board, only about 700 survived. Now, we're going to be analysing data of the passenger list from the Titanic, and here is an example of the first 4 rows of the data set. So let me take you through the first couple of examples to explain it. You'll notice that where we've got SIB-SP and PARCH, we've explained those already, your siblings, spouse, and PARCH. So let's look at our first passenger. His name is Mr. Braund, Owen Harris to his friends. He's a 22-year-old man. He paid £7 and 5 shillings in old money, that's £7.25 in new money, for his ticket. He embarked at S, which is Southampton, and the 0 again survived meant that he died. He was a 3rd class passenger as well. On the other hand, our second passenger, Mrs. Cummings, Florence, and she's a 38-year-old woman traveling with 1 sibling or spouse, possibly a husband, possibly a brother or sister, we don't know, it doesn't tell us, unfortunately. She paid £10, 10 times as much as Mr. Braund, and she got on at Cherbourg in France. She travelled 1st class, and the survive of 1, which means that she survived got on a lifeboat and survived. So here's a data, and like all data sets, it's not exactly what we would like. First of all, in this particular data set I've got, there's only 891 of the 2,200 passengers, but there's other things that I would say were wrong with the data set. So, for example, there's some simple things. You can't see it here, but there's about 20% of the ages are missing, so we're going to have to think about to do something like that. Also, some of the names of the columns and the values I would like to change. For example, if we have a look at the embarked, I'd like a Southampton, Cherbourg, and Queenstown rather than SC and Q. For survived, I would like died and survived rather than having to remember 0 and 1. I also think these 2 columns, SIB-SP and PARCH, are not very useful, and maybe a better column would be family size, which would be SIB-SP plus PARCH plus me. So plus 1. So sibling spouses plus parents, children plus B is the family size, of the group family size on the boat. So that's our data. And the first thing that we're going to do, we're going to go to first of our demos, and we're going to have a look at Excel and Power Query, and we'll start there. So you should be seeing a blank Excel sheet on your screens now. So let's use Power Query, and let's load from a file, from a CSV file. We have our data here, and let's just load that data into Power Query. And here we can see the data in Power Query exactly as I've described. So here is Mr. Brand, who we talked about, and you can see the data as I showed you in the PowerPoint slide. The second record is Mrs. Cummings. And as we said, we needed to make some improvements to that before we even start analyzing it. Now, what Power Query has done for us straight off the bat is load the data in, worked out that the first row is the column headings, used that, and also looked at the types and worked out, for example, that age is a number and so on. And that's great. Now, there's other things that we want to do, and rather than you watch my slow typing, I'll go to one that I prepared earlier on. And this is, and let's have a quick look at that. So on the right-hand side, we can see the steps, and that's where we got by just simply pointing at the file and getting to it. So I said that I wanted to add a survival column, and here I have done that here. So there's a survival column with more intuitive values, and then I can get rid of the survive columns. And then I wanted to change those values. Southampton, Cherbourg, and Queenstown have done that. We have a value of fair in there, but for analysis purposes, maybe I'd like to group them into under £10, 10 to 20, 20 to 30, and above 30. And let's do that. And there, if we look at that, I've got a fair ban column there. Let's have a look at that. And there we go, that's our fair ban column. And what I'm going to do as well is I'm going to have a look, and I'm going to fill in those missing values of age with the mean value, which I happen to know is 30. And I'm going to do things with the passenger class. And then lastly, let's just do one thing. Let's add a column. That's interesting. Let's transform home, and let's come here. Let's add a column, and let's add a custom column, and let's call it family size, and let's say that it's equal to sib_sp plus arch plus 1. So we're creating a new column which is our family size, and let's just do that. There we go, just to show you. Then when we've got our data, we've cleaned it up, we can go back and we can say close and load, and we've loaded that data into Excel. Now we can start analyzing it. And the first way to analyze it, we've just got a pivot table on that data, the most basic way is to look at a pivot table. And we can see already, we can get some information. So we've got 891 passengers in our data set, and we split them in the rows, women and men, and then also by passenger class, first, second, and third, and then 2 columns for died and survived. So already we can see a couple of patterns. If we start looking, the 891 people on board, about 300 women. But if you have a look at the women, most of the women survived. 233 survived, 81 didn't. And if we have a look across passenger classes, we see if you were a first class woman, then your chance of survival was almost about 97%, only 3 out of 94. It gets slightly worse as you go down to second and third class. With third class, the odds are approximately even of surviving. For us men, the situation is much darker. Again, we can see that it's better to be in first class than in second than in third. But by the time we get to it, most men are going to perish, and by the time we get to third class, you've got about odds of 8 to 1 against you, or 6 to 1 against you surviving. Pivot tables are well and good, but sometimes it's quite hard to see the patterns in pivot tables. So of course, what we can do is look at a couple of power views. And again, this is a power view on the same data. Now, this looks like quite a boring visualization. All it is a few kind of bar charts showing passengers by gender, by embarkation point, and by passenger class, and then by died survival. But what I like about this is that we can click on a particular bar in one of the charts, and then it will show that as a solid blue area in all the other charts. So here I am, if I'm clicking on female, I can see, for example, that of the number that died, very few of them were female. If I want to click on third class, I can see, again, the proportions of men and women in third class, and then I can say, okay, what does it look like for the people who got on at Cherbourg? So I think that's quite a useful thing for teasing out the relationships between the variables then, and finding out a bit more about the passengers. This Power View slide is a much more traditional one. We've filtered here on just the women only, and what we're looking at along the columns is the passenger class, first, second, and third. And then along the rows, what we've done is we split that into our fare bands. So we remember that we split bands into below £10, £10 to £20, 20 to 30, and above 30. And what we see is something interesting. In this case, red is survived. And we see that if we just look at the third class, the women who paid less than £10 have got about 2/3 chance of surviving. Whereas as you go down, as they pay more and more money, they've got less chance of surviving. So the women who paid above £30 and were in third class have a very slim chance of surviving. Why that is, we don't know. It's worthy of more investigation. But what I wanted to show here is that here we can see through the visualization a pattern that we might not have seen in the pivot table, and is counterintuitive and leads us on to more investigation. So that's Excel for us. What I want to do now is to go back to our thing, and we've done Excel, and I want to do the same objectives, but now I'm going to use R and our R Studio. And so let me bring that up. Right. So on the screen, we're looking at R Studio. That's the typical development environment for R. And I've got in the top left-hand pane, I've got a code, a short file of code. Our code, it's about 200 lines long, but don't worry, because most of it is green common code, and I'm only going to execute the most interesting parts. So very quickly to introduce our studio, we've got 4 panes. The top pane is our code. The bottom left pane is our console window. Is when we show our results or any error messages, hopefully no error messages. In the top right, we'll see our objects as we create them. And in the bottom right is on this particular tab, we'll see the plots as we create those. So let's get started with R. And the first thing that we do is R has one of the strengths of R is the packages that people can create, libraries. And we're going to be using 2 libraries in particular. GGplot 2 gives very good graphics, and dplyr allows us to transform the data. So let's get started, and let's load in that data set into an R data frame. And we're calling it data frame DM. And if I click on this, we can see the data frame here. And it's exactly the same as we saw in Excel. It's our data frame, and there again we can see Mr. Braun and Mrs. Cummings. Good. So the first thing that we can do is, we can have a look at that. So it gives us a structure, and down here we can see we've got the structure of the data frame. Let me just move that up a bit, that will help. And it tells us the columns, the data types, and it gives us the values of the first few. We can also call summary, which gives us a kind of a very brief statistical summary of each column. So for some columns, categorical columns, it gives us a count of the different values in the column. There's sex, 300 women and 600 men. Whereas for numerical columns like age here, it gives us a kind of 5-point summary. And interestingly, usefully, it tells us that we've got a lot of missing values in there. So that's our first way of looking at the data. We can just call strut and summary. We can also do a table, and that just gives us a count. That's the table of the survive column. As we know, 549 died and 342 survived. We can turn that into percentages, so 61% died, 62% actually. And then what we can do is we can create our first plot. Now, here is a plot on the bottom right. It's not the most exciting plot you've ever seen in the world. It won't win any prizes, but the interesting thing is how little code that we've had to write to produce that plot. So we've called GGplot. We said we want a bar plot. It always does a column by plot by default. And we're saying on the x-axis we want survived. Because survived is 0 and 1, we have to say, well, survived is actually a category. Use it as a category. Don't treat it as a number. So that's our simplest GGplot. Right. Now what we're going to do is let me, if I can move, just move these things a bit here and a bit down here so we can see. What we're going to do some of the same transformations as we did in Power Query. And our first transformation is to create that survival column. And so we're going to create a survival column and we're going to map 0 to survived and 1 to died. We're using the dplyr package here. Mutate is a function of the dplyr package, and we're saying, okay, with our data frame, mutate it, use our data frame, create a new column called survival. Here's an Ifelse function to map it, and as factor means it's going to be a category. So let's just run that. And then just to show you what I've done, we've got 13 observations now. And if I have a look on the right-hand side here, you can see the column that we've just created. Okay, so that's to show you how easy and simple it is to manipulate data with a dplyr in R. And again, we're going to do passenger class in the same way. That's a very similar sort of thing. And here is our family size, the example that I showed manually in dplyr. And here's our formula. We say our family size is my siblings and spouses, my parents and children, and me. And basically what I'm saying is I want it to be a category, but an ordered category. Some categories, obviously, like red, green, and blue are unordered categories, but this ordered category, it's like low, medium, high. I want it, there is an intrinsic order, and when I want it plotted, I want to see 1, 2, 3, 4, 5, 6, and so on. So let's just run that, and we've got family size there as well. We can split things into adults or children, depending on whether they're over 18. And here's the equivalent of our fare band. Let's just do that. Now we've done our transformations and we've done our cleaning, we can start by looking at the data. And I've done in the code, I've done quite a few examples of GGplots. I'll only show you about 3 or 4 of them. But if you want to have a look at the code afterwards, it's available and there's lots. So let's have a look at this one. Let's just run this. And if I just do a zoom and bring it in, here's our first plot. And what we're showing is basically a split on male and female on gender and those who died. And we can see immediately, if we look at our male, that most men died, most women survived. Again, here's a call to it. Basically, we're saying, do a GGplot, put X on the X-axis, do it as a bar chart. In fact, chord flip means instead of doing a column, do it as a bar chart. So we've done our first one. And of course, we can as well, you can see here we do, instead of a stack bar chart, this dodge means that we can do a side-by-side bar chart. Let's have a look at something maybe a bit more interesting. And here's one that, if I just zoom in and show it to you, here's one that's showing 2 variables against died and survived, gender on columns and passenger class on the rows. And again, you can see that it's quite a simple call. Again, we've done this as before, and then we're just saying having this facet wrap feature, and again, flipping, so it's a bar chart, which I prefer to column charts. We can do other things, like we can produce a quick histogram of our ages, and let me zoom in on that one as well. This is looking at our ages. We can see there were an awful lot of small children on the boat. We can see children below about the age of 5, and a lot of people in their 20s and early 30s. And this red dashed line means that it's the average age. So again, it's quite easy to do a histogram. Here we're saying we want a histogram. We want at the width every 5 years. There's some cosmetic stuff. And then we're adding a vertical line, and it's going to be at the mean value of the age, which is about just under 30, and it's a red dashed line. We can also do density plots if we want, and also box plots. This box plot here just tells us that the more money you paid, the more likely you were to survive. And let's just show this last one. And this one is the same as the, let me just go to it, let me just go and zoom in. This one is the same as the second power view chart that I showed. Again, it shows women, and it shows that the in third class that there is this issue with the women that paid the less amounts of money were more likely to survive. That interesting issue. So far, what we've done, excuse me, what we've done is we've done exactly the same as we've done in Excel and Power Query and Power View in a very different manner. But maybe we can do something a bit better than that, a bit more than that. So what we're going to try and do is we've so far have decided and done our own analysis of what contributes to survival, but maybe let's ask R to do that analysis for us. Before that, I have to just tidy up the data a bit more, which I'm doing there. And what I'm going to do now is I'm going to split our data set into two, a training data set and a test data set. So what I've done is I've added a new column, and that new column has basically a random value on each row between 0 and 1. If that value is less than or equal to 0.7, that's approximately 70% of it. I'm putting it into a training data set. If it's above 0.7, that would be approximately 30% of that. Then I put it into a test data set. And we can see up here that we've got a test data set with 246, a training data set with 645 rows. Okay, so first of all, let's create our decision tree model. And let's go here and let's have a quick look at that. So here we are, I'll run it first. And what we've said is we're going to create a model, we're going to try and predict survival, and we're going to try and predict it on these 6 different variables. We're using the training data set, and it's going to be a class, it's going to be a yes, no, a survived or didn't survive. So now we've got our model. Let's quickly visualize it. Let me just do that, and hopefully, here we go. So let me again zoom that. So what it's done is visualized our model for us. Excuse me. And what we can see is it says basically if I know nothing, then basically I'm going to vote that a passenger died, because the passenger has basically got about 63% chance here of dying. However, the first thing I look at is if what's the gender. If it's a male, then we go down one route to the left. If it's a female, we go down another route. Let's have a look at women. It says if women, on the whole, people survived, unless if the passenger class is inferred. If it's not inferred, they've got a 95% chance of survival. If they are inferred, it looks at family size, it looks at where they embarked, it looks at the fare price, and then makes a decision. So that's helpful for us because ours looked at it and also given us an insight on what decision tree would say were the most interesting or most predictive features for survival. But how do we know if that is very good? So what we want to do now is we say, okay, we've looked at it, let's make a prediction with that. So now what we're doing is, let me just run that, and what I'm saying is we're going to use our model, and we're going to use it on the test data, and we're going to do a prediction. So for the 246 rows in the test data, here we've got 246 values either survived or died. And what we're going to do then is with that, we're going to create a new column on our test data set. We're going to call it predicted survival, and let's just run that. And we've got our predicted survival. Now, have we done any good? So let's do a few counts. Let me just run those. So what I'm doing here is I'm saying, okay, let's see where we've counted. And we're counting our true positives, where we got it right, where we said in the test data it was a survived, and we said it was survived as well. We said our decision tree model said survived. And true negatives are whether we were correct as well. We said died, and the predictor and the truth was died. And again, we have false positives and false negatives where we got it wrong. So what's our accuracy? Our accuracy is basically the number of times we got it right over the number of times the total number of times. And you can see down here that our accuracy is 78%. Now, we could have got 63% right by simply just saying that everybody died. So our decision model is providing some benefit. It's providing 78% of accuracy. So we can have some confidence that our decision model is roughly getting it right most of the time. So there we finish with R. To remind you what we've done, we've basically started off, we've loaded the data in, we've done a quick visualization, we've used dplyr then to clean the data and to calculate columns like family size. We've done GGplot to look at it in various ways, bar charts, column charts, box and whisker charts. We then created a model split the data into test and training. We created a model with the training data. We looked at that model. We then applied that model to the test data, and we saw that we had some reasonable accuracy. Right. So that concludes R, and what we're going to do now is, if I go back to the slideshow, we've done R, and our next demo is Azure Machine Learning. And let me just bring that up. Okay. In Azure, Azure Machine Learning, Azure has experiments. The command main module work is an experiment, and I've split up this into two experiments. The first is a Titanic demo prep, and we'll just have a look at that. Let me just click on here. So the design philosophy here is that there's a kind of flowchart design, and we started by loading our data in. That's our top step, and then it goes through a sequence of operations. In fact, these are called modules. And here what we're doing is we're just cleaning the data in the same way as we did with Power Query and R. And very quickly, let me show you, we're bringing the data here. What's nice about this as well is that at any point we can just say, we can just click and we can visualize. And that will give us the data as of that state. So for example, we can have a look at a particular column. It gives us the statistics of the column, and it gives us, for each column, it'll do an appropriate visualization. And then we can say, okay, let's compare age to, for example, passenger class. And here it says, okay, I'm going to give you a box and whisker chart, and from which we can see, on average, people in first class were slightly older than second and slightly older than third. So that's great. We can do a lot just without those inbuilt visualizations and analysis. So let's have a look at one or two of these steps. I won't go through each one, but let's have a look at project columns, our first step. And what we can see is that here what we're doing is we're saying we're starting with all columns, and we're just going to exclude a few columns: passenger ID, ticket, and cabin. Why are we excluding these columns? Simply because they don't have any predictive power, so I'm just getting rid of them. So we go through a sequence of steps like that. One step is quite interesting. It's called the execute R step, and it's where we can write some R code, which is very useful because it means that if there's something that we just can't do by using one of the modules provided by us, I would just do it in R. So very quickly to go over this R code, the bit in the center is going to be familiar. It's exactly as we showed in the R, where we're calculating the survival, passenger class, and family size columns, and we're doing a GGplot of survival. What's interesting here is we're bringing the data in from the top connector with this first statement, map input port, and then when we've modified or changed it, we're mapping it to the connector at the bottom with the output port with that. And that's very useful to do. It means that if we do get stuck, then we can always use R to make a transformation even if it's not available. So what we would do, this is obviously a cloud-based within a browser. We would run it. I'm not going to run it because it would probably take about a minute to do. But at the end of it, the one thing I did want to show you, if I go here and I go visualize, you can see that here we've got our GGplot, because the two output ports, we have one output port that is the data and another which is any visualizations that we did. Right, I'll leave it there. The last thing that I did here is that I saved this data after we'd cleaned it as a data set. I call it Titanic Clean Data. And in our next module, which is, I'm going to call it Model 2, this one, we're going to start with that clean data. Right, so let me just, and let me tell you what's going on here. So we start with the clean data. Again, we're going to project columns, and again, all we're doing here is we're getting rid of the name column because that is not particularly useful. Then we're splitting our data. Our 0.7 here is our 70% on the left-hand node, 30% on the right-hand node, and Azure Machine Learning gives us a lot of modules. Let's have a look at all the models there. Here we have, let's have just a look in classification. If I can open that, you can see there's an awful lot of models there. I've just chosen one, the two-class boosted decision tree. There's no such thing as an ordinary vanilla decision tree. And then I'm training the model with the first 70% of data that comes in from the left-hand side of the split. Then I'm scoring the model against my 30% of data that I've assigned to the right-hand side, my test data, and then evaluating the model. And once I've evaluated the model, what I can do is I can visualize that. And that not only gives us our accuracy, very similar to the number that we got before, about 79%, but it gives us this lovely ROC chart. And this ROC chart gives us a good indication of how well our model is working. If our model was just not working at all, we would get a line very similar to this very faint random diagonal, this diagonal line that you can see very faintly going from 0, 0 to 1, 1. So the more to the right and the more high this chart is, the more the area under the curve that suggests that our model is doing better. And then we've got this AUC, area under the curve, of 85%, which actually says it's quite a good model. So with these other ways, as well as that, it gives us other details about how well our model is doing in these accuracy and recall statistics. So we've been able to do the model. We've been able to evaluate the model. What I would do if I had time would be then to create a web service from the model, but I've got one that I've already created. Once you've built a model in Azure Machine Learning, you create a scoring experiment, and then you create a web service. And then with the web service, let's have a quick look at it. This is one I created earlier. We've got the ability to test that web service, and it builds up a basic form for us. And we can say, for example, let's imagine a 55-year-old male paying £100, getting on in Southampton and travelling second class, because they don't allow speakers to go first class. And I know what's going to happen, so I'm not going to bring any of my family with me. I click OK. It's going to take that data, and let's have a look at the details. It's giving me some details back, and it's giving me the labels, and the last two labels are the interesting ones. Very difficult for you to read, but at the bottom here it says basically that this particular passenger, it would have predicted that they died, and the chance of survival is 1 in 10,000, 1 in 100,000 just about. So no hope for me there. So if you remember, maybe I'll try and publish this service, and you might want to try this service out with the details that you chose when I showed you the picture of the ship and asked you what your CIVSP and your parts details were, and to see if you were on the Titanic, whether you would have survived or not. So we've done Azure Machine Learning, and I think that's what I wanted to say about it. Let's just go back to our plots, and we've done it. And then I very quickly want to show a demo of Rapidminer. Here it is. Let me just bring it into, there we go. Let me just do that. So Rapidminer is very similar, and here we've got, again, on the left-hand side, we've got a set of modules. Rapidminer calls them operators. We bring the operators onto this process canvas. We connect them left to right rather than up to down, top to bottom, and then we can run it. And once it's run, we can see some data. We can see some charts, and we won't go into the details about that. And we also chose to see a decision tree, and here is a kind of nicer decision tree than the one that are produced. As I say, so a very similar design philosophy, and a design philosophy that I think a lot of machine learning predictive analytics tools follow. Okay, so what we've done, if I just minimize that, is we've seen 4 different tools, and 4 very good tools, otherwise I wouldn't have shown them. And I think that they are very helpful when it comes to doing exploratory analysis of our data. And I want to finish off with this quote by Tukey, which is basically saying what I think exploratory data analysis does, which is from the very start of the project, it gets us onto the right path. So we're asking the right questions. We're not going down the wrong road. And he says it's better to be approximately right than exactly wrong. And I think that these 4 tools are all great for exploratory data analysis. As I say, you can use one of them, you can use all of them, or you can use them in combination. So for example, as I've shown, we can use Azure Machine Learning, and we can use the execute R package when we're going to use R. And I think they're all really good tools. So to finish off with, there are some resources and references. If you're really interested in R, the way that I learned it a couple of years ago, started learning, is going on a Coursera course from John Hopkins. Coursera is a massively online course, and they run these courses. They're very cheap or even free, and it's a 4-week course, and it was a good introduction to R. Rapidminer has got some really good getting started tutorials. Download the free starter edition and use those. That's the best way to get started. Azure Machine Learning has great samples, fantastic samples, and lots of good videos and tutorials. What I've done is I have, let me just go to this, I have on my blog, there is all the details here of the resources, and I've created a OneDrive folder which I can show you, and that has got on it all the files, so you can download these files. That's the Excel file, the R file, and the slide deck, and the Rapidminer repository there, and that gives the information. There's also a link to the machine learning workspace, and if you click on that link, you should be able, within your machine learning, once you've set that up, to be able to copy these models across. So let's go back to that. So all that data there, I'll be very interested in any feedback that you give. If you want to give any feedback, that's my email address, mark.wilcock@zomlets.co.uk. The last thing I'd say is I've kind of put a library of I think 6 books that have really helped me learn some of this stuff over the last year. The first 3 books on the left are kind of general books, and the 3 on the right, if you're really interested in getting into R in detail or Power Query in detail. The Azure Machine Learning is actually a free book and a very useful book. Since it's a free book, I put it on my OneDrive, and that's a really good example of setting up a machine learning experiment, doing the training, creating the storing experiment, creating the web service, and then calling it from a .NET, C# or Python code. So I hope you enjoyed that. Are there any questions?
All right. Well, thank you, Mark. That was great content. Awesome demos. All right. As far as questions here, a lot of people were just curious about where the content will be posted. Just to let you know, Mark does have that posted on his website, like the URL link that he has posted right
Yes.
there. And that's on the content is all nicely prepared in his OneDrive location. We'll also get a copy of that on the PASS Business Analytics virtual chapter site for the presentation as well. So you'll see that in the attachments just for a reference point. Um, and the recording, once this presentation is done, we will get that recording posted up later on today. Last time when we had a presentation, there were some issues with our YouTube getting that incorporated into the presentation site. We found the workarounds for that now, so all of our presentations are posted on the YouTube channel for the PASS Business Analytics virtual chapter. So you'll find all previous presentations there, and we'll get this one posted up there later on today. We only had one technical question for you. The rest of them are mainly about the presentation, where to find the material. The one technical one here was in regards to Power Query, and someone had a question about how many rows of data are you available to bring into Power Query?
I'm not exactly sure. I think it would be with the, you can load Power Query to Excel, but you can also load it to the Excel model, the Power Pivot model as well. And the Power Pivot model can take basically millions of rows. So you're not constrained by the 1 million row Excel limit. So I'm not quite sure. It depends on the memory, but I've loaded, I think, 20 million rows into Power Pivot once. I'm sure people have done more than that.
Yep, so that's a good point. So depending on the Power Query, whether you're loading it into a worksheet or loading it into the model directly, and then it would basically boil down to if you are bringing it into the model, whether you're running 32 or 64-bit Excel. So great. Someone is curious, are you by chance on Twitter? Do you have a handle on Twitter?
I do have a handle on Twitter through my, we have a channel for our London Business Analytics group, which is there. And here it is. You can see it at London Analytics. That's where we blog.
Oh, perfect.
Not blog. That's where we tweet, and we tend to tweet around the times that there is a meeting. In fact, we'll be tweeting a lot on Wednesday of next week because we're having a talk on big data visualization, and we're visualizing all the Twitter feeds around a particular hashtag.
Okay. And then someone was also curious, are you by chance on LinkedIn? Is your user group, or are you on LinkedIn? If they
Yes, and
want to
I'll
get
put the
connected
details
with
of
you.
that on the zomlex.co.uk homepage. I'll put the details up there.
Okay,
Let me
great.
show you that page again. Let me go to that. And there's a page, and I'll put the details on there.
And then we have another one here. Someone is curious if they were using the Excel and the Power View inside Excel, is that supported with multidimensional cubes, or is that, what can you use that against currently?
I must admit that I don't know. I think it is, but let me check that, and I'll put a note on my blog if it is.
Okay.
I think so, but let me confirm that later on the blog.
Yeah, and I believe right now with your Excel 2013, you'd only be able to connect to Tabular or the Power Pivot. With the 2016 release, you should be able to connect to multidimensional, from what I've heard. So.
Okay, thanks, Dan. I'm sure that's correct.
And I think that pretty much wraps up most of the questions here. There's a few more just funneling through here. Sorry on the delay. Yeah, and as far as the slide deck presentation, Mark does have that posted on his website, like he's shown the link to.
Yes, on there. I'm just bringing up the OneDrive here. There's a link from the website, and there's OneDrive with all the information. Again, if you have any problems or any suggestions for improvements or any comments, just email me. I'd be very interested to hear them.
Yep, and we'll follow up with that survey that gets done here. I'm looking for people's feedback on that. Some other comments here. We hear excellent presentation, great webinar. This was my first one. Looking forward to more. Thanks for the great information. There are a number of tools that also do some of these same things. What tool do you find yourself going into the most for your initial exploratory analysis?
I have to say I do use Excel a lot, especially now with Power Query. It's the first tool I reach for. Though I am more and more, as I become more and more familiar with Azure Machine Learning, obviously it was just general announced on general release a few months ago, a few weeks ago in fact. I'm tending to use that more and more as I become more and more familiar with it.
And then we have.
There are a lot of good tools out there. I mean, KNIME is another good tool as well as Rapidminer.
Someone is inquiring about, is there any tool that is simple to see the quality of the data before you actually load it?
Again, I think Excel is sometimes is good at that. I think with R, when I did the summary, I did something called summary. It looked at every single column and it gave me, as well as the min, max, mean for numerical columns, it would give me the number of missing values as well. And I think as well in Azure Machine Learning, I brought it up and then I showed the visualizations. I could click on every column and it gave me a visualization of each. I'm not sure if I can do it again. Let's have a quick look. Let's have a quick look. So if I go into Titanic Demo Prep, for example, let's have a look at the results data set. And so let's have a look. So for example, that's telling me a bit. If I have a look at age, you can't see everything on here. It's giving me my statistics straight away. It's also telling me I've got 177 missing values. It's telling me the unique values. So I think, you know, by doing that on each different one, let's have a look at, for example, Fair, for example, or Embarked. Here I can immediately see we've got a couple of missing values in Embarked, this null value here. Mm-hmm. So I think that is a very good way of looking at your data quality.
Perfect.
You don't even have to write any code. You just load it up and start visualizing it.
And someone did want to mention that with using Power Query, you could connect to analysis services, multidimensional cubes. So that would be one way to get the data in, and then you could use Power View on top of that once you have it loaded in a model. Kind of same thing with the new Power BI Designer. You can attach to the multidimensional cubes too. So.
Yes. I mean, obviously with Power Query, you've got a lot of ways here, all the ways of loading data in.
Yeah.
Lots of ways of loading data in.
Well, thank you very much, Mark. Thanks everyone for attending the presentation as well. We had well over 200 people, so that's great to see. Mark, before you sign off, any last words of wisdom or advice for our attendees?
Well, thank you for inviting me, Dan. I really enjoyed it. And maybe it would be nice to go into depth in each one of these in future, each one of these tools in future. And maybe especially, I think Azure Machine Learning is the one that I'll be using a lot in future.
Yeah, that'll be great. And we can definitely, I know Mark Tabludio is also on here as well. And I'm sure he would love to have you do one of their data science presentations as well. So
that'd be great.
Thank you so much.
Sure, we'd love to have you come to data science.
There he is. Hey, Mark, how's it going?
Look forward to that, Mark.
Great.
All right.
We'd love to have you come do some data science.
Yeah, I look forward to that. That would be great.
All right. Well, thank you so much, everyone. Enjoy the rest of your day, your afternoon, your evening, and take care. Until next time.
Okay. Goodbye.